my amazing algebra students. This is Mrs. A, and I love math. Today, we are in our Saxon Orange books on lesson 18A, and then we'll move into 18B. We're talking about like terms and addition of like terms. So the first thing we have to discover is what are like terms. So like terms have the same variables raised to the same powers. Another way to say it is they have the same variable parts. So we're going to look at this problem right here. 4xmp minus 2pmx plus 6mxp. And we're going to think about whether these have the same variable parts, which would make them like terms. Okay, so here I've written down each one of these terms. I've written them vertically so we can talk about them. Are they like terms? So what we have to check is each one of the variable parts. So we ignore the 4. We're just looking at the xmp. We ignore the negative 2. We're looking at the pmx. And we ignore the 6. We're looking at the mxp. Okay? Are these equivalent variable parts? So in order to check, first of all, let's just eyeball them. Let's look. Do we have an x in each one? Do we have an m in each one? Do we have a p in each one? Okay, does order matter when we multiply? It doesn't. So what we're going to do is we're going to check it, though, by making up some values. For 4 is x, m is 2, and p is 6. And we're going to substitute into each one of these to see if we get, indeed, the same value. So if x is 4, that will be the first one here. So we'll put a little parenthesis 4. And m is 2, so we'll put a little parenthesis 2. And p is 6, and we'll put a little parenthesis 6. And then we'll multiply them all together, and we have 8 times 6 is 48. Okay, so the first one equals 48 when we substitute in these values. Then we look at pmx. So p is 6, and I'll put the little dot there. It's a little bit easier. And m is 2, so I'll put a 2 and a little dot for multiply. And x is 4. So now we have a different order, but we really have the same numbers. So 6 times 2 is 12. 12 times 4 is 48. Then we look at the last one. M is first, so we put a 2. Then the x is 4. Then the p is 6. And we have 8 times 6 is 48 again. It does not matter in which order we have the variables. They're each one of these expressions are equivalent because they have the same variable parts. The order does not matter. Now let's talk just a little bit about what the distributive property is telling us. The distributive property tells us that if we have BA plus CA plus DA, now you see they all have an A in them, then that's the same thing as B plus C plus D times A, or A times B plus C plus D. Now let's check. If we're using the distributive property, A times B is AB or BA. A times C is AC or CA. And A times D is AD or DA. Likewise, it doesn't matter whether the multiplier here is on the back or the front. Okay, so I could say B times A is BA, C times A is CA, D times A is DA. They are equivalent expressions. So now, on this board, we have the same problem written down again. 4xmp plus 2pmx plus xmxp. Okay, so all have xmp as a factor. X and P is in each one of them, so we can pull out the 4 minus the 2 plus the 6. And if we distributed that back through, wouldn't it look like this? Or we could pull the X and P to the back and have the 4 minus 2 plus 6 in the front. They are equivalent. Okay, so what is 4 minus 2 plus 6? 4 minus 2 is 2, plus 6 is 8. So 8XMP is the answer. And that's all there is to it. So when we're adding like terms, the statement is at the bottom of your book here. To add like terms, we algebraically add the numerical coefficients. So once you've found out that the terms are like, which means they have like variable parts, then all you have to do is add the coefficients in the front together. And by add, we mean subtract if it's negative. Okay, so you're going to just do the math like we just did. And that's all there is to adding like terms. So now we're going to come back with lots of examples. Okay, so here are two examples, 18.1 and 18.2. And we're going to look for terms that are the same. So we have an x term, and there's an xy term. There's an xy term, and there's another x term. So the two x terms are going to go together because they're like terms. And then we have a 5, but there's no other term that has just a constant in it. So he goes all by himself. So we'll make him a little symbol. And then I have a negative xy and a 2xy, and they're both xy terms. So I'm going to make them a little symbol. And then I group everything together. Okay, so 3x goes with negative 5x, which will be negative 2x because they're opposite signs. So negative 2x. And then the 5. Now I'm usually going to put the 5 at the end. We usually put the constant terms at the end. It's not right if you not wrong if you put it somewhere else, but we usually just stick it there. And then negative xy and 2xy. Since that's a negative 1xy, that's going to end up being a positive 1xy. And do I really need the 1 there? No. Okay, so now let's look at the next one. We have 3xy, and that's an xyz. And that's a yx, but that's the same as an xy, isn't it? So we'll give it the same symbol. And that's a yzx. So no more xy's. So now I have an xyz. And over here I have an xyz. So even though there's a different order, they are the same. We're going to add the xy's together. 3xy and negative 10 yx is the same as xy. So that's going to be a negative 7xy. A 2xyz and a negative 5yzx, they are the same term. So 2 and negative 5 is negative 3xyz. And now it's much simpler because we have added all of the like terms together. So now let's look at the next board. Okay, so again, I have two more examples. 4 plus 7mxy plus 5 plus 3yxm minus 15. Okay, we have a lot of constants in this one. I have a 4, and I have a 5, and I have a negative 15. Then I have an mxy and an mxy. So even though the order is different, they are the same term, aren't they? So let's group these together. 7 and a positive 3 will be 10 mxy. And then 4 plus 5 is 9. Take away 15 is negative 6. And it looks much simpler, doesn't it? So now, example 18.4, we have a 3x and a negative x and a negative 3x. Those are all my x terms. So now I have y terms. A y term, a y term, and a y term. Now I have constants. So let's make a little squiggle for those. There's a constant. There's a constant. So now let's take all the symbols and put them together. Let's put all the smiley faces together. 3x minus x. Now remember, that's a minus 1x. 3x minus 1x is 2x. And 2x minus 3x is negative 1x. Now, do we really need the 1 there? Or does negative x mean the same thing? It does, doesn't it? Negative y, negative 2y is negative 3y minus 8y is negative 11y. And lastly, we're going to put our little curly cues together. 5 and a negative 10 is a negative 5. And we have added all of our like terms. More examples to follow. Okay, so we have 18.5 here, and we are looking at a constant, an x, m, y term, a y term, another constant, a y, m, x term, a y term, and a constant. We have a lot in this one. So let's make the constants squigglies. Okay, so we're going to say we have a squiggly there, a squiggly there, and a squiggly right there. Okay, and this one was so long I had to continue it over here. And then we have an x, m, y term. It's got an x, an m, and a y. And we have another term that we have to check and say, is it the same term? So x, m, y, we'll put a double underline. X, m, y. So even though it's backwards, it's the same term. And then we have a y term. So let's put a caret over the y term. And we have another y term. Uh-oh, now I've got two conflicting marks here. And I think we have marked everything. So let's go through. Everything has a mark. Now you don't have to make marks on your number, but I just think it's fun and it helps me to sort them out. So we're going to start right here. So we've got negative 3, negative 5, and a negative 14. All three of them are negative. So that's going to be a negative 8, and a negative 14 is a negative 22. We have an x and y plus an 8x and y. Remember, this is a 1x and y. 1 plus 8 is 9x and y. And then we have a negative y and a negative 3y. And that is it for the y terms. So we get a negative 4y. And remember, I probably would write this one first and this one next and this one last. But you notice in your textbook they do it any way they want to. Okay, so it really doesn't matter. I generally put the whole number in the back with the one that doesn't have any variables, but your book is not getting that picky yet. Right, so down here, this is your first practice problem. So you should go copy it down and pause your video. All right, so let's hope you paused your video. I'm going to say that's an xy term, and a yx term is the same as an xy term. A 3x and another x term, and then we have a constant. So let's take all of our like terms and put them together. Negative 2xy, negative 4xy is negative 6xy. 3x and a negative 2x is a positive 1x, or just x is fine to write. And lastly, my constant. And that would be my final answer. You can see how easy and fun this is to do. Okay, so let's get our last little board out. And we will be done with this lesson. These are our last 3 practice problems. And you will be ready to do your homework assignment. So here we have an XYZ. We have an XY, so we need to give that something different. And we have an XYZ. So these two can go together, and this one's the oddball. And we're going to have to leave him alone. So 2XYZ and negative 5XYZ, positive, negative, it's going to be end up with a negative 3XYZ. And then we tack this one on, plus 3XY, and we're done. We look at the next one, and we have a YAC. We just have an AC, and we have a YAC. So once we discover that they are the same variable parts, we can add them together. 3 and 6 is 9. 9 YAC. And then this one is lonely, all by himself. We just tack him on. And that is our answer. Now for our last practice. It's a little bit more complicated. Okay, we have a 4. And we don't have any other constant terms at all. We have a negative x, an x term, and another x term. We have an xy term and another xy term. Okay, so we put like symbols together. This one is lonely. You can put him at the back. Okay, we have a x term and another negative x, and a positive 3x is a positive 2x. A negative 2xy and a negative 7xy is a negative 9xy. And again, it does not matter which order you put those in at this point in time. Okay, so later on as you learn more, you're going to see that they do have a little bit more structure. We usually put the terms that have more variables first, but your book hasn't really taught you that yet. So we are done with lesson 18, and I hope you enjoyed that as much as I did. And this is Mrs. A, and may God bless your day.